jaws tightly gripping a piece of pyrite or flint. A spring held the cock in one of two positions. When ready to fire, the pan cover was opened, the cock was flung to its firing position, the jaws holding the pyrite hard against the wheel, and the trigger actuated to release the spinning wheel, the sparks flying into the pan and igniting the charge. Among the advantages, it stopped patrols and guardsmen being seen at night walking about with a glowing lit match. The wheel lock, however, suffered from its complexity, inasmuch as it was expensive to manufacture. Instead of equipping an army, the wheel lock was marketed more towards hunters and wealthy landowners. The next evolution of small arms came from market pressures more than any other reason. Ever in search of new markets, gun makers looked to other, simpler methods of ignition to satisfy an army's requirements and hence large volume sales. Once again, the originality of the snap-haunce is in debate, but German gunsmiths are the most likely. The word snap-haunce means snapping hammer, which is the principle behind this new development. Though there are some variants in design, the basic theory behind the snap-haunce is based on the careful placement of the individual components of the lock. The cock, with its jaws gripping the flint, was now spring-loaded, held in the cocked position with a crossbolt or sear that was actuated by a separate trigger lever. Attached to the frizzen was a concave steel lip tilted up towards the cock. On firing, the cock, under spring tension, would fly forward, striking the frizzen's curved steel surface with the flint, creating a shower of sparks. With the interval out of the horses, the frizzen is then swung up and out of the way as the sparks enter the pan, igniting the priming charge. Hence, flint and steel entered the common vernacular. Seventeenth-century French gunsmiths finally began taking the elemental parts of the snap-haunce and developed the true flintlock. To define a flintlock from a snap-haunce, the frizzen pan cover is one unit held in position with a strong spring. The cock has attached at its axis a tumbler. Acted upon by a sear, it has two positions, half and full cock, and all the mechanisms are hidden behind the lock plate. The flintlock was an immediate success, and because it was efficient, cost-effective and easy to use, was adopted by most armies. The flintlock saw its way onto most weapon systems like cannon, musket and pistol. Another innovation about the same time, and probably brought about to standardize the infantry, was the cartouche. A prepared cartridge, a paper container with a set quantity of black powder and a projectile. The method of use was this: bring the gun into priming position, tear open the cartouche with the teeth, and sprinkle a small amount of powder into the frizzen pan. Close the pan and rest the gun on its buttstock. Sprinkle the rest of the powder charge into the barrel, then place the remaining package, which acted as wadding, and the projectile into the barrel, ramming it home with the ramrod. The gun is now ready to cock, aim, and fire. Of course, with everyone armed with the same weapon, the technology edge seemed to come down to the type and quality of pyrite or flint and the quality of the powder. A good quality flint should last 50 firings before being discarded and a new one put in its place. The powder? Fast and clean burning as possible, although black powder was notorious for leaving a corrosive residue. However, there was always one drawback with the flintlock. It was not true instantaneous firing. In fact, there was quite a time lag from when the trigger was squeezed, the cock fell, igniting the pan powder, and then the main charge discharged the shot. There were two major effects of this primer flashing moments before the gun fires. One, the untrained musketeer would flinch and put his aim off. Or when hunting, the shooter alerted the game to the impending shot, and it would flee unharmed. A good soldier would learn not to flinch and hold his aim true, and the hunter would learn to predict the actions of his game. Reverend Alexander James Forsyth was a keen chemist and shooter, and applied his talent towards solving the delayed firing problem of the flintlock. Earlier in 1800, Edward Howard had discovered an explosive compound, fulminate of mercury, a substance that, when hit or struck, would detonate violently. Forsyth began making his own experiments and developed an exploding powder made largely of potassium chlorate. He then set about developing a lock to utilize this new explosive. The Forsyth lock, or scent bottle lock, because of its resemblance to such, consisted of a small revolving magazine or flask of his new powder. The cork had its jaws and flint removed and replaced with a simple hammer. The gun is loaded the usual way with black powder and shot. Then the magazine is rotated a half revolution, bringing the flask into alignment with the vent. A small amount of the powder would drop down under gravity and charge the vent hole. The magazine was then returned to its original position, where the mechanism held a loose pin above the vent and powder. On squeezing the trigger, the hammer fell, striking the pin, which entered the vent and crushed the powder. Before, it had taken many hundreds of years to see the technology slowly creep forward. After his percussion firing mechanism had shown the way, weapon development steamed ahead. Percussion caps, metal cartridges, breech-charged and rapid fire mechanisms. Forsyth's lock was seized upon by gun manufacturers everywhere, and rapid improvements and variants emerged. The loose detonating powder had its drawbacks, and varnished covered pills of powder were introduced, as too were pinches of powder sealed between two paper discs. That design still survives today in children's cap guns. From there, paper and material tapes of powder packets would be placed across the vent, then struck with a pin. One ingenious method was placing the powder in a small sealed tube of copper, the open end thrust onto the vent, then crushed by the falling hammer. This led to the next major step, the percussion cap. A small brass top hat, coated inside with the explosive powder, was then sealed with varnish, the vent becoming a hollow nipple, which the cap was placed over, then crushed with the falling hammer. Once again, great ideas are never orphans. There were several claimants to this breakthrough, and patents were taken out in several countries, including France, Britain, and America. One minor cause for concern was when the cap would split on detonation, possibly harming the firer. This was quickly resolved with the hammer being hollowed out, so at the time of detonation the cap was surrounded with the hammer head. Armies around the world had invested heavily in the flintlock, and by fortune's way the percussion cap lock could quickly and easily replace the older flintlock. The conversion was lightning fast, and the military forces remained at the peak of the technological pyramid. During the ignition development, other advances were made in loading the weapon. Examples of the breech-loading rifle go back to the times of the matchlock and wheel lock. This method of reloading would be advantageous in confined spaces or on horseback. A fine example of breech-loaded carbines and shield pistols belonged to Henry VIII. Other examples of breech loading were developed for the flintlock, including this ingenious loading method. Shot in one tube and powder in another, both in the butt stock. With the aid of gravity and the turning of a lever, a rotating chamber would deliver first a shot to the barrel breech, then a load of powder.